The next is the concept of basic operations on fractions. And by basic operations on fractions, this simply means the application of addition, subtraction, multiplication, as well as division to fractional numbers. So in this aspect, we are going to be talking about how do we add any two or more fractions, how do we multiply, and so on. So the first set of questions we want to solve is this as follows. So number one, we are asked to add 2/3 to 3/4. So solution to that. Number one, I have 3/4 plus 2/3. So what we do first here is, I will have to consider the denominator of the two. What I mean is this: in any situation whereby we are required to add any two or more fraction, now the first thing we want to establish is to ensure that the base, that the denominator have a common LCM. So initially we want the denominator to be the same thing. But once the denominator are different, then the LCM of the denominator will have to be determined. So I will have to repeat that once again. Addition of a fraction will only be possible in one case, in one situation. And the situation when that thing is possible is when the denominators are the same number. Once the denominators are not the same number, we force them to look alike by what? Looking for the LCM of the denominators. So when we observe the question which we have at hand, we are going to see that the denominator are different. They are not the same number. So it will be necessary in this case to determine the LCM of our denominator. So doing that can be done here. I have my 4 and 3. And remember, finding the LCM of any number means we should keep dividing this number until each number we have here becomes what? 1. So the smallest possible number I can use here first is 2. So 2 in 4 here gives 2. And remember, by our assumption of LCM, division is only possible in situation whereby we don't have a leftover, that is, we don't have the remainder. Once we have a remainder, then such a number is not going to be divided. So 2 in 3 will be written back as 3, because when 2 divides 3, it's going to leave a remainder. And this aspect of mathematics has nothing to do with what? Determining the remainder. Then the next thing is 2 can still be used. 2 in 3 here gives 1, but 3 in 3 will be written as 3, because 3 will leave a remainder, and we are not interested in what? Writing in remainder. So when we observe this, we can see that we are already done with the first number here, 4. It has fully been reduced to what? To 1. So the next attention now is going to be these 2. Now let's think of a number that can divide 3. We know the number that can divide it is 3. So 3 in 3 here is 1. So no need to write this to divide 1 anymore, since we've gotten to its own a here. Now we can see that the two numbers 4 and 3 which I have here, each has now been reduced to 1. So the LCM of 4 and 3 will now be those numbers which we have here. So 2 times 2 is 4, 4 times 3 gives 12. So it shows that LCM of 4 and 3 here is 12. Now the next thing is, how many 4 can I get in 12? So whatever value it gives me, I will use to multiply the numerator. So remember what we have to do now in order to continue with this solution is to say that this LCM divided by the denominator, whatever it gives, we use it to multiply the numerator. So 12 divided by 4 here gives 3. And that 3 times the 3 here is what? 9. Plus 12 here divided by 4, that is by 3 here is 4, and 4 times 2 here is what? 8. And the result gives is 9 plus 8 is 17 over 12. And remember, to express any number in fraction means we want it to be in a proper form. And when we observe our results here, we are going to observe that this is not in its this is improper case. So it has to become, once it is improper, then the only way to present the answer now is to what? To express it as an index number, or to express it in its index form. So to express it in index form simply means to interpret what we have here. That is, How many 12 can I get in 17? We know that is 1. With the remainder of 5, that remainder is going to be written as numerator, then everything over 12, and that is the result of adding 2/3 to 3/4. So number 2, what I have is 7/12 plus 3/8. Remember, adding any 2 or more fraction means we are looking for a situation whereby their denominator will be the same number. Once they are not the same number, then it is necessary what we determine the LCM of such denominators. So and the two denominators we have is 12 and what, and 8. So let us reduce each number until they become 1. So 2 can be used there. 2 in 12 gives 6, while 2 in 8 here is 4. 2 can as well be used. 2 in 6 here is 3, while 2 in 4 here is 2. We shall continue with 2 until it works no more. But 2 in 3 here will be written as 3 because 2 divides 3 gives a remainder of 1. We are not interested in remainder here, so we rather leave this 3 as 3. So 2 in 2 here is what? 1. And finally we can divide with 3, which now gives 1. So we can see that each number has been reduced to what? 1. So the LCM is now going to be multiplication of the results which we have here. 2 times 2 here is 4, 4 times 2 here is 8, and 8 times 3 here is 24. And what follows is my denominator, my LCM here will divide this denominator and multiply the numerator. So 24 divided by 12 here is 2. 2 times 7 here gives 14 plus 24 divided by 8 here is 3, while the 3 multiplied by 3 here is what? 9. So it shows that the final result here is going to be 23/24. And when we observe the result here, we are going to see that it is a proper fraction. So whenever we are asked to solve anything fractional, so it's only proper aspect of it that we can call the final result. So once the result is a proper number, but not just a proper number, but a proper number in its basic form, then that's what we are going to take, or what we are going to regard as our final answer. And the next is number 3. So what we have there is 5 whole number 4/3 minus 2 whole number 4/5. So when we observe this one, we are going to see that it's a little bit different from the first one and the second one that we did. So this is a case of a mixed number in each case. So there are two approaches to dealing with this thing, but I'm going to concentrate on one of the approach. And the approach is I want every number to be written in improper form first. To be in a proper form. So this number in improper form, to make it an improper number means I will say that 3 times 5, that is 15, and 15 plus 4, that is 19. That becomes 19/3 minus. So to express this one as well in improper form means 5 times 2, 10, 10 plus 4, that is 14/5. So that is the first thing that has to be done. And next is we want to consider the denominator. And the denominator the same thing. Once the denominator are not the same, then it is necessary to determine the LCM of the two denominator. And if this thing is done very well, the LCM we are going to get is 15. And what we are going to do now is to say that 15 divided by 3, that is 5. Then what is 5 times 19? 5 times 9 here 45. 5 times 1 here 5 plus 4. That is 9. So there I have 95 minus 15 divided by 5 here is 3, and 3 times 14. 3 times 4 12. 3 times 1 3 plus that 1, that is 42. So we now have 95 minus 42. 5 minus 2 3 so is. So here we have 53/15. And we can see this can't be reported as our final answer because this is a case of improper fraction. As a result, it has to be converted or adjusted to a mixed fraction. To adjust it as mixed fraction means we are going to interpret it normally the way it is here. So How many 15 can we get in 53? That is going to be 3. Because 15 times 3 is 45 with the remainder of 8. So that would be 3 whole number 8 over 15. And remember, the denominator is going to be the remainder, after which 15 divides what 53, and 15 still remains as our denominator. And one other common feature of this thing is that whatever we call a fraction must exist in its basic form. That is, it has to exist in such a way that both the numerator and the denominator has no number or nothing in common. And when we observe this thing clearly, we are going to see that there is nothing common to both the numerator and the denominator, and as a result, we conclude that will be our answer. The next one is this: 4 whole number 1 over 6 minus 1 whole number 5 over 8. Now, to solve this one, I'm going to use that improper fraction approach. So in that wise, I will ensure everything is in proper fraction. So 6 times 4 here gives 24, plus 1 is 25 over 6, minus 8 times 1 8 plus 5, that is 13 over 8. And that becomes, now what we need next is the common denominator. So when we observe these two denominators, they are not the same thing. As a result, it's very necessary we determine the LCM of the two denominators. I have 6, I have 8. 2 in 6 3, 2 in 8 4, 2 in 3 3, 2 in 4 2, 2 in 3 3, 2 in 2 1, and 3 in 3 1. So 2 times 2 4, 4 times 2 8 times 6, it shows the LCM here is 24. And what follows is 24 divided by 6, that is 4. What is 4 times 25? We know that gives 100, minus 24 divided by 8. That one is 3. 3 times 13, that gives 39. So finally, we are going to say 100 minus 39. 10 minus 9, 1. And 9 minus 3 here is what? 6. So that gives 61 over 24. And we can as well see that the result we should have here is the case of improper fraction. And as a result, we have to convert this into a number in mixed form. So how many 24 can we get in 61? We know that is going to be 2. What is the remainder? So to get to the remainder, we are going to say that 61 minus 48, because 224 is 48. So 11 minus 8 here is 3, while 5 minus, so this is 13. So the result is going to be 2 whole number 13 over 24. That's number 4. And finally is number 5. And what we have in number 5 is this: 5 whole number 1 over 6 minus 3 whole number 2 over 3 plus 6 whole number 1 over 2. So to solving it, please, we first of all have to ensure everything is written as an improper number. So to write this one in proper number means 6 times 5 is 30 plus 1, 31 over 6, minus 3 times 3 9 plus 2, 11 over 3, plus 2 times 6 12 plus 1, 13 over 2. So, which is the same thing as, so remember here, we want the denominators to be the same number. So since the denominators are not the same, so it's now necessary we look for the LCM of the denominator. So I have 6, 3, and 2. Remember, my aim is to change each number to what? 1. 2 in 6, 3, 2 in 2, 1. Then when I use 3 here, so 1, 1. So you can see that the LCM of 6, 3, and 2 is what? 6. Now what follows is 6 divided by 6 is 1. 1 times 31, 31 minus 6 divided by 3 is 2. 2 times 11 is 22. Plus 6 divided by 2 here is 3. 3 times 13 here gives 39. So to continue with this, it means we are going to apply the concept of board mass. So we can see after this 31, there are two instructions. The first instruction is we should subtract, the next instruction means we should add. And by the rule of board mass, addition comes before subtraction. So it means we are going to add to 31 before we subtract from 31, or we can rewrite what I have here as 31 plus 39 minus 22 over 6. And that this becomes 31 plus 39. This is 0, this is 7. That is 70 minus 22 over 6. So we are going to have 70 minus 22, this is 8. So that gives 70 minus 22. This is now, okay, this is 6. So 48 rather. So this is going to be 48 over 6. And when we consider this thing, we can see there are many things common here. 6 is common to both. So 6 in 6 here is 1. While 6 in 48 gives 8. So the final result to that is what? The final result there is 8. So that is that on addition of 2 or more, addition and subtraction of 2 or more fractions. So at the moment we are going to shift our attention to that of multiplication as well as division of 2 or more fractions. So we are going to start that by way of example as well. So simplify the following. Number 1, I have 8 times 2 over 3. Number 2, 3 over 4 of 10. Number 3, 5 over 6 times 3 over 8. Number 4, 7 whole number 1 over 8 divided by 4 whole number 3 over 4. And in number 5, we have 5 whole number 1 over 4 times 2 whole number 4 over 5, everything over 3 whole number 3 over 4. So the solutions to number 1, I have 3 over 4 of 10. When we follow the rule of abundance, we know off will later change towards multiplication. So this is the same thing as saying 3 over 4 times 10. Now, since we are asked to multiply, we can see what we have here is a fraction. So for a beginner like this is DSS1 level, I think it will be better. We also express this number in fractional form, and to express this in fractional form is to call it over 1, and we cut where possible so as to arrive at the result. So 2 in 4 here gives 2, while 2 in 10 here gives 5. We can now multiply where possible. 3 times 5 here gives 15, and 2 times 1 here gives 2. But we can see that this can't be our final answer because this is what? An improper fraction. So to make it, to report our final answer now means every improper fraction will have to be expressed as a mixed number. So and expressing it as a mixed number means we have to interpret what we have here. So that simply means 15 divided by 2. That gives 7 with the remainder of 1. And remember, our remainder will be written as numerator. Why this 2? So the denominator of the question continues to serve as our denominator. So in number 2, I have 5 over 6 multiplied by 3 over 8. So we can see everything here is in fraction. So we just cut, that is we divide where possible so as to arrive at the answer. We can see 3 in 3 here is 1, 3 in 6 here gives 2. So we are left with 5 times 1 over 2 times 6. So 5 times 1 gives 5, and 2 times 8 here gives 16. So we can see the result we have here is a proper fraction. And not just a proper fraction, it is a proper fraction in its basic form. So as a result, we conclude this to be our answer. In number 3, what I have there is a mix up there. So I should have solved 3 over 4. Okay, 8 times that one ought to have come up maybe earlier. So we solve number 1 as number 3 now. So that is 8 multiplied by 2 over 3. So remember I said it the other time like this. Nice if we can make this number what? A fractional number by calling it something over 1. And let us observe this thing. Is division possible anywhere? We can see division is not possible. What we rather do here is we multiply. So 8 times 2 here is 16 over 3. But this can't serve as our answer because it is improper. So once it is improper, what it automatically means that our answer is going to be reported. How? It is going to be reported in the mixed form. So that is to interpret what we have here. That how many 3 can we get in 16? We can see that it's 5 with the remainder of 1. And remember, the remainder changes to the numerator. So therefore, the answer there is going to be 5 whole number 1 over 3. The next is number 4. And what we have there is 7 whole number 1 over 8 divided by 4 whole number 3 over 4. Now solving this one also means that I first of all have to reduce, that is change the number I have to improper fraction, because this is given as mixed number. So all mixed number, if it comes in form of question, will have to be changed to improper fraction before we can what? Carry out the required operation. So 7 times 8 here, that is 56. So 56 plus 1 here gives what? 57. So I will have it as 57 over 8 divided by 4 times 4 here is 16, and 16 plus 3, that is 19 over 8. And under fraction, when we are asked to divide, so division usually changes to multiplication. And when division changes to multiplication, what will happen is the fraction we have after that division line is going to change their position. So it's going to be rewritten as 57 over 8 times 8 over 19. And when we observe this thing, you can see that it is possible with cut. So 8 we divide 8 here. 19 in 19 here is 1. While 19 in 57 is going to be 3. So finally, our result here is 3. So finally, in today's class is the question number 5. And what we have there is 5 whole number 1 over 4 multiplied by 2 whole number 4 over 5. Then everything divided by 3 whole number 3 over 4. And what we are to do there is to first of all change everything to the improper form. So this becomes 4 times 5 is 20 plus 1, 21 over 4 times 5 times 2 is 10 plus 2, 14 over 5. Everything over 4 times 3, 12 plus 3, that is going to be 15 over 4. And that becomes, we multiply or cut where possible. Now 4 in 4 here is 1, 2 in 4 here is 2, while 2 in 14 here gives 7. So I will multiply now. So I have 21 times 7, 7 times 1 7, that is 147. So that will be 147 over 2 times 5 here is 10. Everything over 15 over 4. But this division line, I want to write it in other form. That is by saying I have 147 over 50 divided by 15 over 4. And remember, division usually changes to times. So that is going to be 147 over 50 times 4 over what? Over 15. We are now going to cut where possible. We know 3 in 15 gives 5. 3 in 14 is 4 with the remainder of 2. 3 in 27 is 9. 2 in 4, that gives 2. 2 in 50, that gives what? 25. So there is nothing common here again, so we have to multiply. You can see 49 times 2 here gives 98. over 25 times 5 here is going to be 125. So between 98 and 125 we didn't have anything common, and as a result our result to what? Multiplying 5 whole number 1 over 4 by 2 whole number 4 over 5, everything divided by 3 whole number 3 over 4 gives the value of what? 98 over 125. And that is how far we can go with this class. So in the subsequent class we are going to talk about how to arrange fractional numbers in ascending order as well as in descending order, and as well as how do we find mixing values, and also we shall talk about some words problem, that is a word, some set of words, how do we interpret them, how do we translate them into fraction. So I say thanks for watching my channel. Thanks for joining the class.